For decades, stealth fighters lived with an impossible choice. Fly fast and your radar-absorbing skin melts, your heat signature explodes, and invisibility vanishes. Fly slow and you surrender the initiative. So Air Forces everywhere assumed Mach 2 was the hard ceiling for any jet that wanted to stay unseen. Then, in 2025, America lifted the curtain on the F-47. A 6th-generation platform that doesn't just ignore that old trade-off, it makes it irrelevant. Today, we're counting down the 5 most insane capabilities of this machine. But first, the one breakthrough that changes air combat forever. The F-47 is no paper airplane. Boeing is building it. The Pentagon ordered a fleet of over 180. And the first flight is set for 2028. The real question is whether any machine can keep all the impossible promises made for it. We start with the one it was never supposed to deliver. To understand why that claim is so radical, you have to go back to the central problem of 5th-generation fighter design. Speed and stealth were never friends. At Mach 2, the airframe's surface heats past 300 degrees Fahrenheit. Radar-absorbent coatings soften, blister, and lose their signature-killing geometry. Afterburners dump fuel into the exhaust and light up the infrared spectrum like a signal flare. The F-22 Raptor, still the most lethal air-to-air machine ever built, can barely graze Mach 12.2, and only for minutes. Because beyond that, the thermal price becomes unpayable. The 35 never even tries. It tops out around Mach 1.6. This wasn't a flaw, it was a deliberate compromise. The Pentagon accepted that the penalty for total invisibility was a speed limit, but the limit created a strategic trap. In the Pacific, distances are staggering. From Guam, an F-22 needs tanker support just to reach the edge of a contested zone, and tankers are the first things an adversary would target. A fighter that could fly faster and farther without sacrificing stealth would collapse those distances. The math was cruel. If you wanted to penetrate Chinese air defenses on day 1, you had to be both invisible and impossibly fast. For 20 years, military planners knew what they needed. They just didn't have the physics. Then, in complete silence, the laws of the possible shifted. Sometime around 2020, a full-scale demonstrator began flying. No press release, no official program name, just hundreds of flight hours logged inside restricted airspace. The aircraft was never photographed. But senior Air Force officers later confirmed it cracked a barrier that the entire industry had treated as permanent. It cruised beyond Mach 2 while maintaining a radar cross-section smaller than a sparrow. Not a one-time sprint, not a stripped-down test article, a mission-representative stealth shape, holding formation with physics for hours. That demonstrator validated the core idea behind the F-47. If a production version can turn those test flights into an operational weapon system, then every enemy air defense calculus built around interception speed, missile engagement zones, radar sweep times, early warning thresholds becomes obsolete overnight. The question is no longer whether the wall can be broken. It's how the engineers move the wall without breaking the rest of the aircraft, and why that propulsion secret is even more disruptive than the speed itself. The answer starts inside the engine. For decades, fighter engines were stuck in a single personality. You could tune them for fuel-sipping cruise or for combat thrust, but never both at the same time. The F-22's Super Cruise was a revelation, holding Mach 1.5 without afterburners, but even that engine had a fixed thermodynamic ceiling. Push hotter, faster, and you woke up a thermal beacon that every infrared sensor in 100 miles could see. So the Air Force did something radical. It launched the Next Generation Adaptive Propulsion Program. And the winner was a variable cycle engine unlike anything that had ever flown. Think of it like 2 engines sharing the same casing. At cruise, the airflow paths optimize for efficiency, cooler exhaust, lower infrared bloom, maximum range. The moment combat demands it, internal vanes shift, the core reconfigures, and the engine morphs into a high-thrust monster that can sustain supersonic speeds without lighting up the sky. That's the real superpower. The F-47 doesn't just hit Mach 2, it holds it in a thermal signature that, according to the program's architects, stays below the threshold where traditional detection systems can lock on. Afterburners become optional, not required. That one shift alone erases half the enemy's kill chain, but the engine is only half the puzzle. The airframe has to survive the heat without melting or losing its stealth shape. Here, material science took a generational leap. Traditional fighter skins use aluminum alloys and titanium. They're light, but above a few hundred degrees they weaken and warp. The F-47 engineers turned to ceramic matrix composites, materials originally developed for missile nose cones and spaceplane leading edges. These composites stay rigid at temperatures that would soften steel, and they don't require the heavy cooling systems that add weight and drag. Suddenly, the airframe could soak up the thermal punishment of sustained Mach 2 flight without structural fatigue or a bloated radar signature. Even the stealth coatings are different. The old polymer-based radar-absorbent materials, they started degrading the moment you crossed Mach 1.8. The new formulations, still highly classified, are baked into nanostructured layers that shrug off heat the way old coatings shrugged off rain. They maintain electromagnetic absorption at 500 degrees Fahrenheit. Temperatures that would turn a legacy fighter's skin into a glowing target, combined with an airframe that has no vertical tail fins, nothing to catch a radar beam and bounce it back, the F-47 becomes an object that physics says shouldn't exist, a sustained hypersonic ghost. And that reveals the truly uncomfortable strategic truth. All those billions China and Russia poured into integrated air defense networks, the S-400 and S-500 batteries, the over-the-horizon radars positioned along the first island chain, every one of those systems was calibrated for a threat that played by the old heat versus stealth rules. A fighter that can enter the engagement zone at supersonic cruise with minimal warning compresses the defender's decision window to seconds. Launches that once allowed 90 seconds of flight time now give a battery commander 20. Missile envelopes shrink, intercept geometry falls apart, and the entire layered defense concept begins to unravel. But here's what few analysts are willing to admit: the speed is not the scariest part, the range is. Because that adaptive engine in cruise mode doesn't just hide you, it stretches your legs across an ocean. The F-47's projected combat radius exceeds 1,000 nautical miles. That's nearly double the F-22. It means a squadron based in Japan can reach deep into the South China Sea without a single tanker. It means America's air dominance no longer depends on vulnerable refueling chains that a peer adversary would target on day one. And it means the Pacific map, so long dominated by the tyranny of distance, has just been redrawn. Yet speed, stealth, and range are only the baseline. What makes the F-47 a true 6th-generation weapon isn't the airframe, it's what the airframe controls. A fleet of autonomous machines that turn one jet into a squadron and one pilot into a battlefield commander. That's where the equation shifts from evolution to revolution, and why the next breakthrough changes not just how wars are fought, but who fights them. Of all the revolutions packed into the F-47, none is more unsettling to America's adversaries than this. The pilot isn't flying a fighter, he's commanding a fleet. In early 2026, the Air Force quietly selected General Atomics and Endural to build its first production collaborative combat aircraft, autonomous drones designed from scratch to fly, fight, and if necessary, die alongside a manned 6th-generation jet. These aren't modified target drones or remotely piloted toys. They're self-directed combat systems with onboard AI that can scout ahead, jam enemy radars, carry a full weapons payload, or deliberately fly into an inbound missile to save the manned aircraft behind them. And every F-47 can orchestrate up to 5 of them at once. Think about what that does to the kill chain. In a traditional air-to-air engagement, a single fighter detects, tracks, decides, and fires. The pilot is sensor operator, tactician, and shooter simultaneously. Now multiply that by 6. The drones fan out across 100 miles of battle space, silently fusing radar and infrared data into a single shared picture. One drone illuminates a target with a low-power laser designator, while another launches from an angle the defender never sees. A third drone, running electronic warfare, saturates the enemy frequency bands with noise so the opponent's situational awareness collapses, all while the manned F-47 remains electronically silent, invisible, giving up nothing but the kill. That connected brain runs on silicon that didn't exist 10 years ago. The F-47's core processor handles terabytes of sensor data every second. Radar returns, infrared tracks, electronic emissions, threat libraries, all fused in real time and projected onto an augmented reality helmet visor. The pilot doesn't read instruments, he sees the battle space rendered around him, with threat rings, intercept vectors, and recommended firing solutions painted directly onto the sky. And because the architecture is software defined, the aircraft can receive new combat profiles mid-mission. A sortie that started as an escort can morph into a suppression of enemy defenses strike with a data upload, not a landing. But the computing power that makes the F-47 a command node also makes it a delivery platform for weapons that rewrite the laws of terminal defense. Hypersonic air-to-air and air-to-ground missiles are no longer concept art. The F-47 will carry weapons that exceed Mach 5, skip off the upper atmosphere, and perform terminal maneuvers at forces that would snap a conventional airframe in half. Against that, no current ship-based or ground-based interceptor has a reliable kill probability. And for the threats that get closer, directed energy weapons, solid-state lasers fed by the aircraft's enormous electrical generation capacity offer a silent, invisible, immediate defense. No magazine depth, no warning time, just a beam of coherent light that detonates a warhead or blinds a seeker in the seconds before impact. Here's where the nightmare scenario for planners deepens. The F-47 doesn't just fight a single battle, it forces a systemic reorganization of an enemy's whole defense budget. Countering an aircraft that is supersonic, stealthy, and escorted by autonomous wingmen means investing simultaneously in quantum radar, directed energy countermeasures, satellite constellations, and AI-driven air defenses, none of which are cheap or mature. Beijing's entire anti-access strategy rests on keeping American carriers and bases at arm's length with long-range missiles. A platform that can penetrate those zones faster than the defenders can cycle their radars makes that strategy a race against physics they can't win. Moscow, already stretched by production bottlenecks, now faces a jet that renders the Su-57's claimed stealth advantages marginal by comparison. And yet, the most profound shift isn't even technical, it's doctrinal. For the first time, the Air Force is betting that a high-cost, low-volume platform around $300 million per jet can achieve air dominance not through mass, but through asymmetric capability offset. Each F-47 becomes a miniature system of systems node, a mothership that extends its consciousness across a dispersed, resilient combat cloud. That works exactly until the adversary fields something comparable, which brings us to the uncomfortable question hanging over every classified briefing room. While America races toward 2028, what is already being refined in the wind tunnels and software labs on the other side of the Pacific? And when that rival 6th generation jet breaks cover, will the F-47 still be the apex predator? Or just the first of its kind in a new, much more dangerous era of aerial warfare? That's where we're going next. So here is where the story lands, and it's darker than most open source analysts are willing to say. The 47 is not being built to fight the wars we had. It is being built to win the war that hasn't started yet. And the proof is in a detail that almost nobody outside the program has fully absorbed. The jet that rolls out in 2028 isn't the final version, it's Increment 1. Under the Air Force's Digital Century Series model, the 47 is designed for modular evolution. New engines, new sensors, new weapons packages slide in as threats shift. By the time a rival 6th generation airframe emerges from the shadows, and Beijing systems are estimated for the early 2030s, the 47 will have evolved at least once, possibly twice. You can't outdevelop a platform that was never frozen in the first place. That is the true strategic payload. This also settles the question that opened this film. Can speed and stealth coexist? The answer is yes, but only if you rewrite the engineering assumptions that made them opposites. The adaptive engine broke the thermal ceiling. The ceramic composite airframe absorbed the punishment. The coatings refuse to degrade, and the result is a fighter that can pierce contested airspace not because it outruns physics, but because it convinced physics to play on its side. The wall is gone, and it's not coming back. But capability without credibility is empty. So the final piece is this: the 47 has already flown. Not the production jet, but the demonstrator that logged hundreds of hours in real airspace before a single public word was spoken. That flight history means the program isn't a bet on lab results. It's a validation of operational maturity. When Chief of Staff General Alvin confirmed the jet would exceed Mach 2, nearly double the Raptor's combat radius, and operate with autonomous wingmen. He wasn't reading from a concept paper. He was describing something that had already left the ground. The only thing left is to build enough of them, train enough of the new breed of commander pilots, and integrate the entire kill web. That takes time, but not as much as the enemy needs. And that brings us to the final, quiet truth. Air superiority since the Second World War has been the American military's foundational assumption. Every ground operation, every carrier strike group, every logistical chain assumes the sky is friendly. Lose that, and the entire force becomes a target. The F-47 is the insurance policy. It says to any adversary, your kill chains will be tested, your radars bypassed, your interceptors out-energized, and your airspace penetrated before you can close the decision loop. Strategic deterrence in the 21st century isn't just about nuclear arsenals. It's about the certainty that if you contest the sky, you will lose it. That certainty is what the F-47 restores, and that is what changes everything. This isn't the story of a faster jet, a sneakier airframe, or a smarter computer. That was never the point. The point is that for 50 years, the contest in the sky was a chess match. Move for move, sensor for radar, missile for jammer. The F-47 changes the board itself. Speed and stealth, once locked in a zero-sum equation, now multiply each other. Range no longer depends on tankers that an adversary can shoot down, and the pilot is no longer alone. He arrives with a swarm of machines that don't fear death. The only real question left isn't whether the Pentagon can produce enough of these jets fast enough. It's what the rival response will look like, and what happens when two ghost fleets, both invisible, both faster than sound, finally meet. If you want to see that story when it breaks, make sure you're subscribed, because the silent war for the skies has already begun, and you won't hear it coming.